Hello, everybody. Welcome. I hope you're having a wonderful day so far. My name is Michael, and I'm back teaching myself some Python on December the 15th of 2024. I hope you're having a great day so far. Welcome back to the stream. Let's go ahead and let the Discord know that we are live. Okay. Great. All right. Let me get the stream selected here. All right. Cool. So we are going to take a stab today at the chapter 4 reinforcement problems. So let's go ahead and get this loaded up. Okay. All right, now let's go ahead and get started here. All right. Describe a recursive algorithm for finding the maximum element in a sequence S of n elements. What is your running time and space usage? All right, so let's say we have def find max. You take in sub sequence S. So we need to make a recursive algorithm for this function. So we need a base case. So we say hey Gina, how you doing? Welcome in. You're the first one here. All right. Describe a recursive algorithm for finding the maximum element in a sequence S of n elements. So find max of some sequence. You sending out packages? So if we need okay, how can we write a recursive algorithm? So we need to have a base case. So our base case would be what? There's no more elements in this sequence. So if n elements. I got out, Gina. Okay, so how can I write this recursive algorithm? So we need a base case, right? So our base case would be that we've already searched through all of the sequence, right? I think that is the method here, right? It would have to be, the base case would be that we had already searched through all of the elements in the sequence. So we can say So we take in sequence so we call find max again on the length of the sequence. Okay, think about this, Mike. So we have find max, and it takes in some sequence S. So we need to find oh, this is gonna be a tough one, guys. Brain's not working here. So my base case would be that I need a base case, right? My base case is that all elements have been viewed, right? So like we can't end unless we view all the elements in the list. So we'd have to find, so if if we need to then capture, we need to say that the call, so our base case is if all elements have been viewed. So we need to say if the if index is greater than the length of the sequence, we're going to return we're going to return biggest. So we need to set biggest equals to is equal to sequence 1 index 0, right? So the biggest is going to be the first value right off the jump. So if our index becomes larger than the length of the sequence S, we're just going to return the biggest. Else we will say, we will call find max function on for index in range length of the sequence find max of sequence plus of index plus 1. So if we say if we're going to implement a find max function that uses recursion, we need to first establish that the biggest number is just going to be the first value in the sequence. So biggest is equal to the sequence at index 0. If index becomes larger than the length of the sequence S, that means we've iterated through all of the values in the sequence, comparing them, and we can return the biggest at that point. Else, for every index value in the range length of S, we want to find max on this. So for index in the range length of, so 0 to, let's say that, let's try to use an example here, right? So let's say that our S is equal to a list of values. We'll say it's 4, 2, 6, 8, 3. Right, so obviously 8 is going to be the largest one. We have 5 values in the list. So the length is going to be 5. We're going to go 0, 2, 5. So 0, 1, 2, 3, 0, 1, 2, 3, and 4. We want to, for index, we want to call find max. We want to call the find max function on the sequence again at index plus 1. So we also need to say if the index return biggest if sequence at index so we say like if sequence at index is greater than biggest, we want to set biggest equal to sequence at that index. Right? So, hey Sports Showroom, thanks for coming in. Hey Christy, thanks for coming in. Appreciate you guys joining me this afternoon. What book is that? Yeah, we're reading Data Structures and Algorithms in Python. This is a collegiate level textbook going over DSA and specifically that of Python. You can find this book online. We're currently at the end of chapter 4. We're doing the end of chapter 4 reinforcement problems. Or I also provide a copy of this PDF in my Discord linked below, where I just have compiled all of my study resources into one location. So if you want access to everything that I'm using on stream, just into one centralized area, feel free to join the Discord link below. Thanks so much for joining me, though. For those that are new, I have my name is Michael. I'm 25 years old. I graduated back in 2021 with a Bachelor of Science in Human Biology and a minor in Chemistry. And I'm teaching myself programming in my free time and documenting my progress via stream as a way to hold myself accountable and gain new skills. So right now we are working on trying to write a recursive function for finding the max and given in some sequence. So we need to return, we call find max on the sequence, but it needs to be returned somewhere. So that return find max that. No, we'd say this is going to return a value. So we need to say that value is equal to find max. So if index is greater than the length of the sequence, we return the biggest value, meaning that we've already went over all of the index values in the length of the sequence. So length of the sequence will be 5. If we get to index 5, this will be index 4. So we need this is greater than or equal to length of the sequence, return biggest. Else, if the sequence at that index is greater than the largest value, we set biggest to it for every index in the range of the length of S. So find max gets called, it returns. Hey Mike P. Funk, how's it going? I appreciate you coming in and stopping in. Good to hear from you today. Thanks for coming in. So we're trying to write this recursive function, you guys. I'm trying to figure it out. So let's say that we start on value 4. So it's going to start on value 4 in our list right here, right? It's then going to propagate down to, it's going to say, okay, the index that we're on, right, is not anything. So we don't return biggest here. Else, so 4, right? And then it goes down and we'll look at if else for, so I think we need to take this for index if, then do this. So I don't think we need this part. We would call find max on the next index value, compare it. So if we're on our node here, we would transition to our next node and we would be evaluating so what happens if I do this one? What happens if I run print find max of S1? Okay. So it's not localized, so we need to get index before here. No, I don't even think we need to capture what index place we're on. So this will take this value and save 4 as biggest, right? It'll save that. And then it'll save 2 as biggest in the next one if the index returned oh hey Wing Hong, I appreciate you coming in. Good to hear from you again. Thanks for joining me. So this is hard. Okay, so we have a biggest value that gets saved initially to the first data point in our sequence. So we would then say we need to establish our base case. So our base case would be that we have looked through if S becomes greater so if S becomes greater than the length of S. So if S becomes greater than the length of S, meaning that the sequence we provide no. So if we provide a sequence of digits, if Angela, almost reaching 500. Yes, thank you so much, you guys. We probably are crossing over 450 right now during this stream. So just unbelievable. Super ecstatic about that. We are growing so fast here. It's just really mind-blowing. So thank you guys so much. Okay, so recursion is hard, man. So we have some sequence, and we initially set the biggest value to the first value in the sequence. Then we need to establish our base case is if something becomes greater than or equal to the length of this thing, because we return biggest. What, though, is greater? Is going to be the returned sequence value. So this has to be an index here. So we have to return an index value for the largest one. So geez, man. Okay, so we return the biggest if the index becomes larger than the length of the sequence. Else, if the value, so we need to take this, we need to establish an index for the range of the length, right? If the sequence at that index is greater than the biggest, we return the biggest. If we return set biggest to that, and then we call find max of the next sequence plus 1. So if we ran this, we get an error saying if index, so this is most recent callback, traceback, unbound level, cannot access local variable index where it's not associated with a value. So because we need to return the index plus 1 with find max as sequence. So index plus 1 will get returned, meaning we'll move to the next number. Legendowski, I don't know, I'm wrong, but you need to initialize index? Yeah, it would appear so. We don't have it initialized because we're getting that unbound local error. So I thought that by returning okay. For index, if the length of the sequence, so the sequence plus 1, find max on the index. Well, if we find max on sequence at index 2, so that's not what we want to do. We don't want to do that, actually. So let's back it up. I'm going to take a peek at, there is a find max function that we wrote in here. Where was it? Let me see. Find max. Sure, hold on guys. I thought we had a max function that we had in here. Yeah, here we go. Okay, so we have find max, which takes in some sequence. So we assign biggest to 0, and then this is where we need to replace recursion, right, with recursion. So so instead of saying we call see if you index equals 0 at line 5. Oh, I get what you're saying, like as initiated beforehand initially. So, right, if we have biggest equal to 0, and then we need to replace this for loop with the actual recursion, right, that's happening. So biggest equals 0. We're going to call the function again, find max for the sequence plus 1 for the next number in the sequence. We need our base case, right? So if we're going to call find max for the sequence plus 1, that's going to then move on to index 0. Oh my gosh. So we return, at the end of this, we're going to return biggest, right? But we need to find out at what point do we call find max back for the next value in the sequence. So we increase the sequence value by 1. Index plus 1. So then it would have to go, it would move to the next value of the sequence. So if we say index is equal to 0, and say if index becomes greater than or equal to the length of the sequence, we want to return biggest at this point. And then we're going to call find max, else we call find max recursively back onto itself, and else if sequence at index is greater than biggest, we'll do biggest is walrus operator sequence at index. I don't know if this will work. If sequence at index is greater than biggest. uh, assign biggest, right? Is there a way to write this as like a comprehension? Can I? Biggest is equal to the sequence index if the sequence index is bigger than the biggest. I'm not sure how to do this in comprehensive form. For okay, so biggest, we'll just say this. If sequence is big, index biggest is greater than biggest, we will say biggest is equal to sequence at the index, right? At that index. Okay. So now what happens if I do this? Int object not scriptable. Subscriptable. Int object not subscriptable. Square brackets to indices or slice that is an integer. Integer is an iterable. So biggest is equal to the sequence at index 0. At index. If index becomes greater than the length of the string, we return the biggest value. Else, if the sequence at index is... So we can't define index here. Because if we do that, so if I put index outside here, not scriptable. No. Okay. We have to get the almighty orb involved here. I am trying to write a recursive function for finding the max value in a sequence. Let's walk through it step by step without code. Understand the base case. Recursion requires a base case to stop the function call from calling itself infinitely. What is the simplest scenario that we know the answer? If the sequence only has one element, the element is the maximum. So the base case is if the sequence only has one element, that's the maximum. So we'll say index 0. We'll take the next index. If we do index plus 1, 2 will become our next index 0. We need to do a comparison if define the recursive case. Recursion works by breaking the problem into smaller subproblems. How can we reduce the problem size? Split it into two parts. The first element, the rest of the sequence. Compare the first element with the maximum value of the rest of the sequence. Plan a comparison. At each step, assume the rest of the sequence has a maximum value recursively determined. Compare the first element with the rest maximum to determine the overall maximum of the current step. So, right, it's going to first go through and find max for our sequence as. It's going to assign the biggest value to the first number in our sequence. Boom. That gets assigned to biggest. If the length of the list, length of sequence becomes less than 1, meaning that there's 0 elements in there, less than or equal to 1, that's our base case, that there's only 1 element in there, meaning that it is the maximum, we return biggest. Is less than, because or equal to 1, or because it's less than 2. But greater than 0. If it's 0, if the length of the list is 0, that means we don't have a biggest. So if length of the sequence is less than 1, you return none. There's no value in this list, right? So if it's less than 1, we return none. If it's less than 2, meaning that it is 1, we return the biggest value, right? Else, if the sequence at whatever index is greater, at index 0 is greater than biggest, we return at index 0 return sequence, find max of index so we can't call index find max of a, we need a sequence here. So the sequence would be find max of sequence plus 1. If I do sequence plus 1, if I just add, that adds literally just 1 to my sequence value, so that wouldn't work either. All right. Hey Justin, thanks so much for coming in. Appreciate you stopping in. Thank you for the support. Welcome. So, right, this is our base cases, meaning that base cases, so, right, are these ones. So if the length of our sequence is 0, we return none, meaning that there is no maximum And then if the length of the sequence is less than 2, meaning there's only one value in the list, we return the biggest, which is just that first value. Else, we're going to call else if the sequence at index 0 so I feel like we need to get in, we need to somehow tell the program to move to the next index and compare that value. But we saved it previously. And so if we iterate over to the next index plus 1, this gets us to create a sequence. So for your base cases, can you ask you when you will stop your recursion? So the recursion, if the length of s is less than 1, meaning that if the sequence we provide has 0 length, it will return none. There's no value in the sequence, so that we cannot find a max. If the length of the sequence is less than 2, meaning that it is 1, we return biggest. No, we don't want to write elif, right? We return biggest. Else, we need to say if the sequence I don't know what to do. I'm struggling, guys, to be honest. We need to make the comparison, right? But we also need to recursively call the function back on itself. But we need to call it back on itself with a, an increment to the sequence somehow. We have to decide how this sequence is going to, adjust its values. Now, because you have to physically check each one of the values to be the max, you would have to check over each element if they're not in order. If they're in order, you could just return the last value in the list, right, for the maximum. But we're assuming things are not in order here. So if we have a sequence, we define the biggest value to the first one in the list. Okay. If the length becomes okay, got you. Okay, so I'll give GPT this so far. Okay. If length is less than 1, your base case for an empty sequence and it should return none. However, Python will raise an index error when trying to access S0, so if the sequence is empty, this needs to be executed after checking. Okay. So we'll take this. This has to be done down below the base case. There. Right? Like so. So then, boom, we'll take that and put it in. Why is it still typing? Joe. Okay. The current implementation has an issue because the variable biggest is in reference okay, so it just doesn't like my whole thing, whatever. So we have to define biggest here. Hey Jaded Room, thanks so much for coming in. I appreciate you. Says how long you've been programming for. I started about 6 months ago at the beginning of June 2024, end of May. I started with Python CS50P, and then I started doing independent projects and reading textbooks like the one we're currently doing, data structures and algorithms in Python. Hey Vance, thanks for coming in. Okay, guys, we've been working on this for a while now. This is a struggle, but it's okay. We're getting there. So we have our base cases. If it's less than two, we return biggest. Else, biggest is equal to the first value provided. If so, not that. So this is going to return a value at the end. So we need to call find max on a sequence with the next index but it's going to find max on I that's what I'm struggling is I can't put an index into here because I need to only allow a sequence. So how can I adjust the sequence down somehow, either up or down, to get to the next value? That's what I'm struggling with. Like we like someone said it wants us to maybe pop. Like we can pop the value. So biggest equals to that, okay? We set the biggest to the first value in the sequence. Then we say for I in range length of the sequence, do we need to create a new slice from that list on? No, because that will just that'll be duplicating elements we don't necessarily need. So for index in the range length of s, if the sequence if oh, this is ridiculous. I cannot wrap my head around this. For index in the range length of x, that'll give us 0 to 4 or 0 to 5, 0 to 4, 0 to 5, 4 included. I don't know how the peak method works, to be honest. I've never used it before, so you're going to have to help explain. So the only thing though is we haven't learned about queues and stacks yet. So I don't think we need to, use a queue or a stack, like, because they would have told us about them if we needed to put them in. Like, so I'm trying to use what the book has provided us thus far. Like, it's not going to make us use things that haven't taught us yet. So we assign the biggest value to the first data point in the list. Okay. We need to call find max back on the sequence again, but the sequence has to be reduced by a value. So we just need to capture this first value in the sequence. In the first run, we're going to start with the length of all 5. We are going to take this value. What if we do it from the opposite way? What if we start with all 5 values, look at the 3, okay, say that, or look at the 4 rather, because it's the first one. Look at the, no, it'd come out of here. So look at the 3, okay, save the 3. Okay, then call it back. Look at so for index in the range length of S, 0 to index will be 0, which will come in here. So if the sequence at that point index, I feel like using a for loop just kind of defeats the point of the recursion though, because the recursion is supposed to replace the for loop. Gosh, this is what I have so far. Your code has a few structural issues that need to be addressed. Let's identify and fix them step by step. Biggest is referenced before assignment in the base case for the single element. The biggest is declared after the base case but is used in the second base case. This will raise an unbound logic error. Biggest is misplaced. This needs to be used logically within the recursive case, but currently it's in the wrong location. So I thought we couldn't assign it up front. That was part of the issue. Gosh. Correct structure. Add the recursive case. No, stop. Okay. Why are I asked you not to give me code? Gosh, so annoying. If the sequence is empty, there returns no maximum value to return. Simply stop and return the value none to signify. Base case 2. If the sequence has only one element, the maximum value in the element itself. There's no need for further comparison or recursion, so we return biggest. Break down the sequence into 2 parts. The first element, the rest of the sequence. Assume that the rest of the sequence, smaller in size, has a maximum value which you can determine by calling the same function recursively. Compare the first element with the maximum value from the rest of the sequence. If the first element is larger, so we say if biggest is greater than the find max of sequence, return oh my gosh. Use recursive call reduces the size of the sequence by 1. Eventually you'll reach the base case. Let's take 4 to 6 maximum. We'll start with the first element 4 and call the function for the rest of the sequence 2. So do I need to establish an index variable? No, you don't need to establish an index variable because you're working with the sequence itself rather than indices. Make your answers more concise. Stop rambling. So how can I reduce the size of the okay, what if I go like this? Biggest is equal to find max of sequence of the sequence for the recursive call. You can reduce the size of the sequence by passing only the rest of the sequence, excluding the first element to the. This can be done by slicing the sequence from the second element onward. That's what I thought. Like, okay, so you do have to slice. I didn't want to slice, but so find max. We find a slice and say biggest is equal to index 1 through, and we save biggest. Biggest is equal to s sub 0, s0. So that'll save the 4. It'll then call the recursive function on the slice through. We need to say if s sub 0 greater than the biggest, no, because this is going to assign the biggest to the 0 value at the beginning of the list. So if biggest oh my gosh. So we'll slice from the next point onwards. So okay, let's break this down. I'm struggling here, guys, to be honest. I'm definitely struggling, but we're learning, we're trying. So we're going to enter the function and assign the biggest value, the variable biggest to the first value in the list. I'll just say first, right? Oh, fine, biggest, whatever. Biggest gets assigned to the first value in the list. If that list is less than 1, we return none. So biggest can't get assigned here because it'll try to do that for a list. We need to elif, if length of list is less than 2, we return sequence at 0, right? So we're not returning biggest. Else, we're going to run biggest is equal to 0. So we'll assign it here. We will call find max on recursively at this point. So we have 4 saved as our biggest here in our node. Okay? We call find max for the next slice of index 1 through. So this will take, the next slice will be 2 all the way through 3. In this iteration, biggest gets saved as sequence 0. Right, so biggest gets saved as sequence 0. We call, so it'll be saved as 2. We call then 6. We call, and then it gets saved, biggest becomes 6. So in each run of this, we have biggest being saved as the next number in the list. When we get to the point where there's no more, when the length, so we have to do the check here on this value next to override biggest. So say if return that list. we're going to return the find max list back to the function. Oh my gosh. Initialize biggest outside of your max function. No, we need to keep our biggest initialization happening inside the max function, because we're not, that defeats the whole purpose of using a function if we have to define things outside. So that wouldn't be the right way to go about it, unfortunately. So we assign biggest here to the first value. We call recursively on find max for the slice, which will then be reduced by 1 if biggest, which will be the first value, 4 in this case, is greater than oh my gosh, this is ridiculous. Your code is almost correct, but it's missing logic to compare the first element biggest with the result of the recursive call. Find max. Let's define the logic conceptually. Key missing step. In the recursive case, else you're calling find max for the slice on the rest of the sequence, but you're not comparing biggest, the first element, with the maximum to the rest. You need to do this comparison before returning a result. Get the maximum of the rest of the sequence by calling find max. Compare the biggest first element with this result. So if biggest greater than find max through here, because this will assign that biggest value to here, then we will return, oh no, we don't want to return, we return biggest here? Yeah? No, because we can't call biggest greater than this sequence. No, not even, can't do that either. So we can't call find max on the rest of the sequence, compare the first element with the maximum of the rest, return the larger value. Call find max on the sequence, compare the first element, S0, with the maximum of the rest. So oh my gosh, I cannot wrap my head around this. So we're close though. We're really close. It says so. If the sequence, so get the maximum of the rest of the sequence by calling find max 1 through whatever, through the end. Compare biggest, the first element, with this result. If biggest is greater than, this is going to return me a list though of finding max of all the way to the next sequence. It's going to return this value here, return that, so it'll get to the last one, return 3. It'll compare 3 to 8, return 8. Compare 8 to 6, return 8. Compare 8 to 2, return 8. Compare 8 to 4, return 8. If biggest, because this returns a value at the end of it. Biggest greater than the sequence. No. How can I compare biggest to a slice? To compare biggest, the first element in the maximum to the maximum value of a slice, you need to first find the maximum value of the slice using recursion. Use the function call find max one slice one of the sequence one forward, which returns the maximum value of the rest of the sequence. After getting the maximum value from the rest of the sequence, you compare it first with the element S0. You return the larger value between, okay, equals to temp, return temp. Int and none type. So this gives, okay, so then this none right here is getting us, so if we continually go forward, so what if I remove this base case and say this? None type, not supported. Okay, so it didn't come from that. Extreme Tech, thanks so much for coming in. Because this guy, I start learning Python from Crash Course book. Awesome. Let me know how that's going for you. How's the Crash Course book going? Yeah, Vance, I'm trying to solve it before I'm not trying to look at answers. I'm trying to solve it. I'm really trying to solve it here before I give in. You can call another helper function inside the find max function and use helper function recursively. Saber asked, do you plan on dabbling in LeetCode / HackerRank? Yeah, maybe eventually after we complete the DSA book. I currently don't have any like super desire to grind through practicing of like LeetCode problems. I'm not, applying for interviews or something. I have a bachelor's of science in human biology and a minor in chemistry. I work as a formulation chemist, and so I'm not like grinding for interviews or nothing. So if we at the end of the book, we will definitely be doing LeetCode practice problems as like warm ups, but just need to first learn the material. Okay, so what do we need to do to this code, you guys? So we are saving the biggest value as the first one. We're returning S sub 0 at the end of this. So if it becomes 1, so we don't need to assign biggest then. We say it returns S sub 0, so this will return a single value. So if biggest so this will return some value. If temp because temp biggest might become none on some iteration, because if we try to go forward one, biggest becomes none. I think that's where we were getting that error from before. So if length is, Vance says you just assume base case is where length is equal to 1, not less than 1. So if length of S is equal to 1, we're returning none, or is less than 1, so 0. Return none. If length of S is equal to 1, we return this value, S of 0. Okay, so that will return the when we break down. No, so when we break down all the way through the next slice, the next slice, the next slice, the next slice, we get 3. We return 3 to the previous recursion. We then check so temp will be saved as this value at the end of the recursion trace. So at the end of the recursion trace, we're going to get 3 sent back. Right? So then temp at the end of the recursion trace is going to be 3 inside of a list. So if temp at position 0 is greater than biggest at biggest, return biggest. Like that? No. So this is an int object because it's a 3, a single 3. But then we get biggest not supported between instances of int and none type. So biggest would become you just assume base case is length equal to 1 and not less than 1. So if the length is equal to 1, we return S sub 0, right? Meaning that we only have one item in the list, and we return that value. Else, we assign biggest to that value, the first value in the list. This should give us that temp, not scriptable. So return, then check if sequence 0 and sequence 1. Then check if sequence 0 is greater than or equal to sequence 1. If it is, then just remove sequence 1 and call function again. And return sequence 0. And then check if sequence 0 is greater than sequence at 1. And then return is f sub 1 is greater than s sub 0. We're going to return s index 1. And then else we're going to call see, I think it defeats the purpose of doing the recursion function by defining a global variable and unfortunately outside of the function. Like, we should be able to solve this with everything being with internal inside of the function, from my understanding. So how can I so else if the sequence at index 1, so return 0, so if oh, this is frustrating, you guys. I cannot figure this out. You call the function which results in the maximum value of the rest of the sequence. Comparison. After getting the maximum of the rest of the sequence, you compare it to the first element, S0. Return the larger value. Return the larger value between S0 and the result of find max. When you keep the greatest number at index 0, it makes it easier to return the base case. So sequence 0 is greater than sequence index 1 is better to use than removing sequence 1 if true filters and items than calling max sequence. Oh. Okay. So if the length of the sequence is equal to 1, we return 0. So this will, else we need to write sequence of 1, index 1 forward. So this is going to return the 3. Else, if we're going to make a slice and return this list. And then we say we call find max on this slice to find the maximum of it. Of the next slice. So now we need to return this value. No, we don't need to return the value, the function, because it's within the body. So we say find max I'm going to say this. What happens if I print this guy? None. It's okay, right? It recursed all the way down to 3, just like we anticipated, right? It recursed all the way down to 3, and it returned. So now we need to take that value and compare it to the previous values. So we have a none type being compared. So then let me say biggest is equal to sequence 0. What happens if I print biggest here? So I print biggest here, 4, 2, 6, 8, 3, with some nuns in between, just because of how these are ordered, I believe. So then we need to compare. We're getting nuns here, though, when we shouldn't be. How can we get rid of these none values? Yeah, we're not trying to use the max function that's built in. We're trying to recursively find max using our own comparison logic. And, you know, it's to actually, it kind of would defeat the purpose to use the find max function that would just find it right away. So you can sort the sequence and do binary search. Yes, there's all sorts of ways, you guys, that we could solve this in different ways. But again, like I said, is we are trying to solve this according to the parameters of the problem. Like this is a question that we've been given. We can't just make up, you know, parameters and be creative to solve it a different way. We're kind of stuck here with what it's asking us to do. The none values are being generated from the recursive call. Yeah. So it's being printing. So what happens if I print just the biggest? What do I get? Just 4 and none. Four and none. So you first secured the biggest. Oh, we're doing this. Hold on. That's why. So let's see here. Boom. Oh, hold up. Find max. Okay, 4. Okay, there we go. So we're saving 4. So now what do we if we say print the sequence slice from 1 forward, what do we get? We get 2, 6, 8, 3. So we get the slice that we're needing. Okay. So what happens if we call find max on this sequence slice, right? And print that. Okay, we get the nones. So then we need to do the comparison. If biggest is greater than sequence at index 1, go forward. I don't think this would be the right way to do it either. So that prints us out nothing. So what if we print this? No? None. So we're getting none now for this. So if biggest is greater than S1, find max. Recursively call find max of the next slice. Okay, let's take this and see if GPT can give us any hints here. You're on the right track. There are a couple of things that need to be adjusted. Missing return. In your else block, after recursive call find max, you don't return anything. You return the result of the comparing the elements. And return. Do we return the result? Like this? You need to store the result of find max and compare it with biggest. Okay, so we will call find max and store it as value is equal to find max if value is greater than biggest. Set biggest equal to value. Oh, this is annoying me. If this is annoying, guys, I'm sorry. Hopefully this is entertain. I don't know if this is entertaining me mentally struggling through this. Like, I guess it kind of makes things more humane. Like, this is like maybe more relatable. But if this is boring, please tell me. I apologize, and we can move on and do something else. And I can take another stab at this in some more free time. But let me know. Your else block after the recursive call, find max this slice. You don't return anything. You need to return the result of comparing the current element biggest with the maximum value from the rest of the sequence. You're calling find max slice, but you're not capturing its result. You need to store and compare it with biggest. You compare it with the first element, S0. Do we need to return biggest here? No. Return the larger of the two values. Capture the result, compare it to the biggest, and return the larger value. Your code is almost correct. There are a couple of things to refine. No need to assign biggest inside of the else block. Since you're comparing S0 and the rest of the recursive call, you can directly handle the comparison without needing to reassign biggest. No need to assign biggest inside the else block. Since you're comparing S index 0 and the rest of the recursive call, you can directly handle the comparison without needing to reassign biggest. Okay, like that. The list only has one element. No, stop showing me code for the 20th time. Gosh, I wish I would just remember and learn things. Like, stop showing me code. It's so annoying. Your logic is almost correct, but there are small issues. The S0 is greater than, when S0 is greater than val, the maximum number becomes the rest of the sequence. You return S0 instead of leaving. When S index 0 is greater than val, the maximum of the rest of the sequence, you should return S0 instead of leaving the return statement empty. If the first element S0 is greater than the maximum value of the rest of the sequence, val, return S0. See, this just isn't working. Ugh. Okay, we got some messages. I'm sorry, guys. You need internet spectator. Thanks so much for coming in and leaving some messages. I appreciate you helping me out here. You need returns in all paths of your function. Okay? Imagine this, you are going deep inside the last element, which is 3, and then you're unfolding the recursion when you reach the base case, which from the last element, which is 3. Exactly, okay? What happens when you return 3? Assume that is maximum right now. Then after you return 3, what do you have to do? Compare that 3 with the current list of the elements. I think in your case it should be 8, return 8. Try to read this, it will help you. I think slicing logic is confusing. Line 12 is incorrect. You aren't storing anything in val. Add an else statement if not greater. Add an else statement if it's not greater than what will you do? Return the S1. Add an else statement if not greater than what will you do? So if value that this so this is going to return back 3 in this value at the end of this sequence. It's going to then say if that 3 is less than 0, the less than not supported between instances of none type and int. So if this is giving me an int, why am I getting a none type here for my s is 0? S sub 0, which should be 8, but this program is just not working. I'm getting this error, type error. Value equals the function, but the function returns a value at the end of the recursion. So if value your current logic checks 3 less than 8. It's not less than 8. What? 3 is less than 8. What? I'm not following you. Your current logic checks 3 is less than 8. It is not less than 8. It doesn't return anything on line 8. Line 8 is this. Returns 0. Oh, hold on. Like this. Okay, let's see. Okay, we get, right, we have the class, we have the 3 that's being captured here. We have, and then we have the 4 other values of where the recursion needs to unfold and compare, and these aren't being captured anywhere. So we need to capture these values as not none objects. They need to be captured somewhere. So where do we need to capture them? Right, so this is housing our 3. This is supposed to be 8, 6, 2, and 4. But we're not saving these anywhere within our function. So do I need to save as biggest is S0? I thought that GPT said we didn't have to do this. No, that didn't do anything either. Else biggest, I won't say biggest, we'll say if what about that? Ugh, not access because we're signing val before so we're trying to do a determination here. So we'll do this. So we're still getting this type error. Check if on line 13 use print. Anybody have any ideas? We're struggling through this one together. We're never gonna forget it, like Mike P. Funk said. We're never gonna forget it after this, but we're struggling through this one together. Okay. Let's give it the yippity and see what she says about this. Nearly correct. There's a small issue. If S0 is greater than val, the function doesn't return anything. You need to handle that case by returning S0 when it's greater than val. Else, return S0. Oh! Oh! We did it! We did it! We did it! Hello! Hello! Woo! We did it! We did it! Yes, yes, yes! We did it! She hates me now. Oh, real life cowse module import just now. Cowse.cow. Instead of not .cow, it's cowse.dog. Bark. We got it, guys. We got it. Oh my gosh. Okay, so it was literally just an if-else statement that we had to do here. That was it. Just 4 lines of code we could not figure out. Oh my gosh. That took us an hour and a half. Do you know how much we could have got done in our project in an hour and a half? Oh my gosh. Oh, that's brutal. Feels good. Feels good. Okay, so our base case, right? Let's go over this together, you guys. Right? So we are describe a recursive algorithm for finding the maximum element in a sequence S of n elements. Now, this wanted us to just describe it, but I chose to write the algorithm to get more practice with it. So we've given some sequence S. We have a base case where we check if the length of the sequence is equal to 1, we're just going to return that value, S0, because that is going to be, if there's only a 4 in the list, then we return 4, right? All right, we initialize a value to be returned by find max all the way for the next iteration through the sequence. So we will continually recur down, saving the value all the way down until we get only one value in our remaining in our out of this slice. We will slice by 1 every time down our list until we get to only one value left, right? At this point, we will do a check and say, okay, if value that we got to is greater than S0, from the previous find max function, right? It's going to start unfolding and making these comparisons and returning either value or the previous S0 used in the previous recursion. And so if we run this, let's add in a couple more numbers. Right. Now let's see what happens. Boom, we got 40, the highest number. Woo! All right. Let's catch up on the chat here. Thank you guys so much for joining. We got 26 people in here. Wow, you guys are awesome. Thank you so much for helping me out with this problem. We had a lot of help from the chat here solving this. We learned a lot going forward. So, but we do have another part of the problem we need to answer here. So let's get quickly caught up on the chat. Ben too, thanks so much for joining and helping out. Said you can store biggest as parameter. You don't need to check when do a compare check and when return biggest. Gotcha. All right. How about Brumby's fan 11? Thanks so much for coming in. I appreciate you joining today. How about setting the val first before doing your if statements? Exactly what we did. Perfect. Thank you for that input. Spectator, nice job. Nice, well done. Great. Round of applause for everybody. Cool. Good. Anthony, it's just part of the problem, I guess. I mean, it's not optimal, right? Because you're having to recur through every list, do a comparison, and unfold. So this will most likely be an log n or O of n time if I just off the top of my head. So, but then you have to unpack and do comparison. So let's go ahead and line 11 is goated now. I thought it wouldn't work. Yeah, me either. It's interesting. We had to find some way to reduce the sequence though, right? Because that's key with recursion is we have a base case. We have to meet a base case at the very last iteration through whatever recursion we're doing. We have to meet the base case, and then we also have to, in order to get to that base case, we have to reduce or change our input by some sort of value each time through the recursion, or else we'll get stuck in infinite recursion, right? Over the same parameters. So we had to slice through the list each time and shrink it by one, just as if you were reducing a value by one each time until we were left with a single value in our list, and then it unfolds doing all the checking and then returns just the value that was overall, right? Now, this is going to be interesting because just like Anthony is saying, this is going to use some unnecessary space. I can already see it now, right? We're trying to find the max of a function, and we are taking a slice and making a list every single time. We're taking new slices reduced by one every single time. So we are technically doing like O of n plus O of n plus O of n plus O of n, like O of n minus 1. So I think that this would have a total time complexity of O of n squared. Right? Because we're not only finding the initial, we're slicing n a number of n times, right? So this is O of n squared. Would you guys agree? For the time complexity, worst case scenario, O of n squared. What do you guys think? Because we are taking slices in relation proportional to n. We slice n minus 1 times, right? O of n squared. Yes, people are agreeing. Woo, we're getting this stuff. Let's go. We're cooking, boys. We're cooking now. Let's go. All right, feels good. All right. Sorry about your ears if I just blew them out. I get excited sometimes when I'm getting this because I'm putting in hour and a half, 2 hours on this one dang problem. I better get something out of it. Oh my gosh. Like, I better get something out of this hour and a half. Sweet. Anthony says the time is still O of n, but space becomes O of n. So I thought the time complexity would be O of n squared. We are creating n slices or n minus 1 slices of n. So wouldn't this be O of n squared? Let's give it the GPT here and we'll have it congratulate us. Boom. Okay. So for the time complexity, am I making slices proportional to n minus 1 for a O of n squared? Yes, you're right in observing that slicing is proportional to n minus 1 with recursive call. This introduces a performance concern. Why is the time complexity O of n squared? Slicing. Each time you pass the slice to the recursive call, you're creating a new list by slicing the original. The slice operation takes O of n time, where the n is the length of the list. Recursion. The recursion depth is n, so you're reducing the sequence size by 1 each time in each recursive call. You're slicing the list of n minus 1 minus 2 all the way down to 1. Thus, at each recursive step, you're slicing, which adds O of n to work, and thus this happens. So the total time complexity is O of n for slicing in the first call, O of n minus 1 for slicing in the second call, all the way down to O of 1 for slicing in the last call. Summing up these gives you total time complexity as O of n squared. Improving efficiency. You can avoid the slicing, which is primarily caused by the quadratic time complexity, by passing an index or using another technique. Yeah, right. So we originally were trying to use index because we know just by nature that we were having to increment over this list, which is going to increase the time, yeah. All right. Let's see here. Mike P. Funk says space complexity is separate from time complexity. Gotcha. When you have O of n from stack space, but each thing is on the stack has O length of slice. Put factors in overall. You're right. Yeah, the slice causes it to be O of n squared. Okay, so then, ow. Whoops. Bumped my hand. Okay. Come on, let's keep rolling over my blanket. So then, if we need to say, the find max function makes n minus 1 slices, or makes n minus 1 slices of n, thus leading to a big O of n to the power of 2 time complexity, right? So then for space complexity, though, I'm going to be honest, I don't remember it talking about space complexity in the chapter at all. Did it talk about space complexity? Section 1, chapter 1, space, lots of words space in chapter 1. Chapter 2, namespaces, instance spaces. Come on. Click, 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 click. Chapter 3. Okay. This is chapter 4. This was just calculating disk space, computing disk space, memory space. Okay. So a recursion trace of the linear sum function for a small example is given in figure 4.10. For an input size of n, the linear sum algorithm makes n plus 1 function calls, hence it will take O of n time, because it spends the constant amount of time performing the non-recursive. Moreover, we can also see that the memory space used by the algorithm is also O of n, as we use constant amount of memory space for each of the n plus 1 activation records. Computing disk space. Our final recursive algorithm, overall disk space. What do you guys say? So space will be O of n due to the recursive stack. It is the same as time complexity. It should be the max size of val, which is the max size of the array. Okay, so your space usage in terms of your memory, you're storing each of these values. Now you create a stack with each new slice, right? That then gets unfolded and removed. So you're creating that stack of slices proportional to n minus 1. So you would have lists. You would have the number of lists you would have would be equal to n. So for a total space complexity of O of n. But those lists themselves contain data itself. So on a local level, you have O of n, and on a global level, you also have O of n. But on the local level, it's O of n for that slice, right? Does that make sense? How does that sound? Each layer in the stack has slice length, space, and there are n layers in the length, n minus 1, n minus 2, n. So you sum that up and you get n times n plus 1 all divided by 2. So you're storing an array in each layer of the stack. So it's n plus 1. So it's the summation formula, which we know that summation is, right, the summation formula is, is the summation formula quadratic, or is it just n? Well, summation is just n because of that problem we looked at earlier, right? Imagine a list of integers, yes. S1, S1 minus 1, S1 minus 2, S1 minus 3, all the way to 1. Yeah. So what I'm getting at is, in this specific problem, we are first going to save the data point 4 in our memory, right? We then save the slice of, or we save the original sequence S, right? We then save on top of our stack, I'll say that this is stack 0, right? This is stack position 1, stack position 2, stack position 3, stack 4, yada, yada, yada. So if this is our stack, right, we have our original sequence, we have a slice of sequence minus 1, we have a slice of sequence minus 2, all the way up until we get 1 right here, right? And so then these are then removed one by one in the stack via the stack's definition, right? We remove things from the top of the stack before we can access stuff on the bottom, which is kind of like what recursion is. So my only thing is so the overall memory space of the stack as a whole would be n, right? Because we're storing in proportional n spaces in memory. But what about on the local level? What about within inside of here? Right? This is going to be an array itself of digits, like x, y, z, yada yada. Then the next one is going to be just x and y, right? And then the next one is going to be just y. So on the local level, you have duplicates of data happening. So what does that account for? You know what I'm trying to say? Right? We have a global level, all in all, proportional to of space allocation to n, right? We have 4 or whatever, 5 places, our length of 5, we have 5 stacks we're creating 5 stacks, right? Or pancakes in our stack, for lack of a better word. But each one of those stacks, each one of those pancakes is dense in its own way, Right? So how would we account for that? It is the function that is stored in the stack. It is the function that is stored in the stack, not the value. So you're saying that the slice itself is stored in the stack. Exactly. So this means sequence minus 2 as in sequence minus 2 indexes. It's missing 2 indexes from the previous sequence. So yeah, the function call is in the stack, but the function call is bringing with it the stack of the lists, the slice of the lists. So what my question is, when we're determining space complexity of a recursive algorithm, do we look on a local level of each level of the stack, like what is the density of that pancake, for lack of a better word, or do we look at it on a global level for the entire stack as a whole and its relation to n? Does that make sense? That's my question. Let's poke at the Jippity here. So let's say I am trying to now determine the space usage of this function. I know that this is acting as a stack where each level in the recursion is n minus 1, n minus 2, dot, 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 all the way to 1. Now, do we define the space usage on a local level for each stack and its data points, each stack level, or do we just care about the entire stack as a whole and its relation to n? When determining space complexity for a recursive function, we focus on the total space used by the recursion as a whole, which includes both the space for the call stack due to the recursive calls and space for data structures, slices, additional variables, etc. Okay, the call stack. Each recursive call adds a new frame to the call stack, and each frame holds the function's local variable s and val in your case. The state function of the function, whether the function was in its execution. In your case, each recursive call adds a new frame to the function find max, and this continues for n levels of recursion. The stack depth is proportional to n because each recursive call, the size of the list reduced by 1, leading to n calls before reaching the base case. Slicing space. You're also creating new lists each time you call s of index 1 forward. This new list takes up additional space, and since you're slicing the list down, the space used for this list is O of n. For the first slice, O of n minus 1 for the second slice, all the way down to O of 1. Therefore, the total space used by the slices is O of n squared. So it's space complexity. Now let's combine these two factors. The call stack adds O of n space because there are n recursive calls. The space for slices adds O of n squared space due to the list slicing in each recursive call. So the overall space complexity for the function is O of n squared due to the combination of the slicing space and the space needed for the recursion stack. Key point, you care about the total space used by both the recursion stack and any additional memory allocation, like slices, as the recursion unfolds. In this case, because of the slicing, the space complexity is dominated by the O of n squared term. Interesting. Recursive functions are going to make use of the call stack, so they need to be accounted for. You look at all of it, I think. It's not acting as a stack, it is a stack. Every programmer has a stack allocated to it to store things like function calls and local variables. No need to get asked GPT Anthony's cooking. Generally, every thread there also gets its own stack. if you debug your program in VS Code, you'll actually be able to see the call stack and what it stores. Max recursion depth of O of n, where each level contains at most O of m, then O of n, then total space complexity is O of n times m. Space complexity is accounting for recursive stack n and values in the val space stack n squared. So the total space usage of find max is O of n plus big O of n squared, which reduces down to just big O of n squared. Stack memory and has a garbage collection. Every time a function gets called, it gets added to the stack until it finishes the call. Got you. So with recursion, you can see how that could get out of control. Yeah, definitely. If you have so many depths that your stack becomes so large, but then you would obviously have to override the recursive limit using the OS module in Python. Right. Okay, so does that make sense? The total space usage is O of n squared. The this is for the entire stack. And then O of n squared, this is the sub-level recursion of slices of sequence S slicing, right? Stack sub-level. You can use dynamic programming or catching as well. Most modern languages as compilers will also have a max recursion depth turn on by default for this reason, but that's later on. You don't want one bad loop that's used for all your computer's memory. Got you. So yeah, so like we learned yesterday, and when we were finishing up reading chapter 4, is that if you guys remember, Python has a recursion limit built into it, and or is it within Python or is it within the operating system? I can't remember, but you use the OS module to actually override the recursion with these functions here. Where was it? Get recursion limit here and set recursion limit, right? Oh, sorry, it's not OS. I'm sorry, it's sys, the systems module. But I know we had some. Is this right though, guys? Is it O of n squared for the space usage total? I know we had some back and forth on if it's O of n or O of n squared. What would it be in this case? But okay, but let's go ahead, and I think we are good to move on to number 2. Okay. So, oh boy. Draw the recursion trace for the computation of power 2, 5 using the traditional function implemented in code fragment 411. 411. Okay. Here's code fragment 411 here. So draw the recursion trace for the computation of the power function. Okay, let's see here. So in our power function here, we take in a value of x and we raise it to the power of n. So if n is equal to 0, we return 1 because raising anything to the power of 0 is just 1. So we return 1. And else we return x times the power of x of n minus 1. The power of n minus 1. So then, let's see here. Recursion trace for this would, if a recursion trace would look like, oh, hold on. Hey, what's up? Hello? Whoops, sorry about that, guys. Okay. So to draw a recursion trace for this guy, we would need to, so what's our power 2, 5? So we would call power on 2 and we'd call it on 5, right? Also, as a heads up, if you use indices and not a slice, then you actually don't need to store a copy of the array at each call stack. Yeah, right, because we wouldn't need to store the slice array at each call stack. It would just be that individual data point indice, right, would be at each stack, and so it would be in a constant time for an indice. Interesting. Okay, so 2 to the 5, 2, 5 goes down to, so we compute, we go down and do x. This will come down and run power, recur and run power of, oh sorry, it'll run x, it'll run, returns the value of 2 times power of x, 2, and 4, right? This goes down to 2 times power of 2, 3. This goes down to 2 power 2, 2. This goes down to 2 power 2, 1. And then this goes down to 2 times the power of 2, 0, where we will return, we return 1, right? 1 gets returned here. And then what gets called 2, what gets returned here? This 1 gets returned, and then 2 times 2 to the power of 1 times 1, right? That'll be 2, that returns 2 here. This goes here. 2 times 2, right, I'll just use the 2 out front here. 2 to the power of 2. So this is 4 times 2, this returns 8. 2 times 8 to the power of 3. Wait, hold on. 2 times x times, oh, whoops. No, not 8 to the power of. I highly recommend running your Max program in debug mode to see the actual stack trace. Okay, we'll do that after this. Technically, Python also makes this tricky. Someone correct me if I'm wrong, but you could also pass the slice by reference and not value. Then you would save that space as well. Instead of passing a slice, you just pass the index. That's what I was saying above, but technically in like C, you could just pass pass a pointer to the array and still do it the same way. But yeah, I guess you need the offset, which is the same anyway. Okay, so hold on. What I think I'm kind of lost in my trace here. So we return 1 at this point, right? Because we're down to our base case of n equals 0. So we return 1, and what do we do with this 1? Well, 1 gets returned. It gets multiplied by return 1. So 1 gets returned, meaning that we met our base case. So 1 goes here, 2 times so we return 1. What do we do with this 1? Well, we call power n minus 1. We return 1 for that. I'm having confusion. What do we do with this 1 that is returned? So the 1 is returned when n equals 0. Um, when we reach our base case and return the 1, where does the 1 go? We're returning 1 here, and then we're loading this 1 back into our previous level as 2 times two times 2 to the power of 1. So now this one will return, this returns x times x to the power of 1. This returns 2 times 2 to the power of 1, which equals 4, right? This then returns 2 times 2 to the power of 2, which equals 8. This returns 2 times 2 to the power of 3, and this returns 2 times 2 to the power of 4. So this would be 2 times 2 is 4 times 2 is 8, so 16. and this is equal to 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 36, right? And so and then this returns 2 times 2 to the power of 5. Which gives 36 times 2, 78 times 2, 146, 156. No, what am I trolling? So what exactly is happening here? Why even have the recursion going down if we're not actually doing anything with these values that are being returned? Return the value of power, call x minus 1 times x. So it's going to return 1 and this will return 4. What do you guys think? So let's say when we reach our base case, we don't do anything with that value. So what is the point of recursion here? The recursive function you've written is to compute. The recursion uses you to break down the problem computing powers into small subproblems. However, this is a small mistake in the return statement when the recursive call is missing a multiplication operation. Here's how it should work. Base case n equals 0. Any number raised to the power of 0 is 1. Return 1. Multiplies by x. The correct version. When the recursion reaches the base case, it returns 1. This is the termination condition, so no further recursive calls are made once it reaches. When the function is called recursively, it keeps reducing n by 1, multiplying the result each time by x. This means that the recursion is gradually building up the product that results in x to the power of n. 2, 3 would work like this. Without the multiplication, return x. So for this specific function that we're working on, once we hit the base case of 1, it just returns 1 to the previous call. But 1 isn't being used anywhere. Like, it's not being summed. Like, what's the whole point of it? Like, I get that it will return that answer for that specific condition, but why even call a recursion? Like, we're not summing these values to get this final value, right? Hey, Anish, thanks so much for coming in. I appreciate you stopping in. We aren't doing anything with the one that is returned besides using it to catch when we raise to a 0. You're right to point out that the value of one return when n equals 0 isn't being used directly for anything else besides serving as the base case. However, the recursive nature of this function is what allows us to build up the value of x to the power of n step by step. Here's how it works. Base case is equal to n returns a value of 1 is crucial because it provides a stopping point. This is anchored in recursion. When n is greater than 0, in the recursive call, the value returned by the base case is used as the foundation for building the final result. Even when 1 itself isn't used after the recursion reaches the base case, it's vital because it's part of the recursive structure that enables us to calculate the power. Example, let's trace the function step by step. So 2, 3 calls 2 times power of 2 times 2. Power 2 times 2 calls power 2, 1. Power 2, 1 calls 2 times power 2, 0. Power 2, 0. Here, the base case is hit and returns 1. Now the recursion starts unwinding. Power 2, 1 returns 2 times 1 equals 2, 8. In the way the 1 returned from the base case, it serves as the base for the multiplication at each step level of the recursion. Each recursive calls multiples x by the result of the next recursive call. In summary, the 1 returned by the base case is not used in a direct way, but it's crucial for the recursive step. It acts as an anchor for it to unwind. My question though is why even like unwind? Like, why even unwind? Because why not just return this value? Why not just do x times x times Okay, we don't want to use a final value after the recursion completes because the purpose is just to print the numbers, not return anything. The recursion is focused on printing, and there's no need to capture or return a final value. Yes. You're doing recursion. The only way to reach the main thread again is to unwind, which in other words will pop the call stack. Again, you should run your max function in the debugger. So my question though is why did we have to unwind this function or this power to do it in the first place? Why did we have to compute all of these individual recursive steps just to solve this one power? Power, because it's not like a summation, right? We're not like summing or making comparisons to previous returns. Why are we recursing here even in the first place? Like, that's how the function works. You can do it iteratively too. Yeah, definitely. You'd have to say like for, the values in the range of up to the exponent, you multiply by those, whatever, you multiply n each by each one, right? So you could do it, iteratively as well. This is the same question I had with the max function. Oh, so I'm just basically saying like, why are we even really doing this? Like, why are we using memory allocation to compute smaller exponent values like along the way? Like, why are we even doing this? Recursion is useful when the problem can be broken down into smaller and smaller problems. It's not just for printing values, but for solving problems in a divide and conquer way. So then for this specific problem is like, what would these sub calculations be used for? Like, why would they even be necessary to compute if we're just trying to solve this original top level function here? The book is just teaching you recursion. It's not the case that this is a good use case for recursion. Okay. Because like in this function, we return a result that is used that we do work on, right? We do a partial power, we do some work and return an individual result at that point. So like this when 1 gets returned, it gets plugged into here. 1 times 2 times 2. It's necessary to compute the problem at hand. So then are you summing these values? You're not like summing here anywhere, right? So you're providing these values at each point and returning them. So 36 gets returned, but what does 36 do into this function? 16 gets returned to this function, but what does 16 do for this function? It gets multiplied by x. Oh, so we're turning this value and multiplying it by x. Okay, so that's what gets placed into here, right? So we're returning, ah, so if it's getting returned as the power value, 1 is getting returned as this, so then 2 times 1 is equal to 2. But the power of 2 is 4. 2 times 2 to the power of 2. 2 times 2 to the power of 2 is 8. Oh no, no, power of 2 times of 2 to the, okay, so sorry. 2 times power of 2 of power of n minus 1. So 1 gets plugged into here, and this becomes 2. 2 gets plugged into here. 2 times 2 becomes 4. 4 gets plugged into here. That's 2 times 4 is 8. And 8 gets plugged into here as 2 times 8 equals 16. But 2 to the power of 5 is not 16. When the function When n equals 0, the function returns x, 2 in this case. Two times 8, 16. So I've propagated this all the way back up, and we got a final value of 16 here, which is not 2 to the power of 5. Wait, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the power of 4. Oh, did I forget a step? Oh, I forgot a step here. That's why. Okay, let's back it up, back it up. We forgot a step here. So 1 gets, so this becomes 2 to the times 1 equals 2. This becomes 2 times 2 equals 4. This becomes 2 times 4 equals 8. This becomes 2 times 8 equals 16. This becomes 2 times 16 equals 36. 1, 2, 3, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Like that. For a total answer of 36. That's what it would look like. Okay. So let's go ahead and type this out in our problem here. So let's just write this out real quick. If return 1 else oh, sorry, you're right. 32. My bad. Wrong math. Okay. Okay. That does that. So then we'll say, I'll draw the trace here. So power of 2, 5 goes down to power it comes 2 times power of 2 5 minus 1, like that, right? This now becomes 2 times the power of 2 times 4 minus 1. I'll just put in the 4 here to make it easier. Three. Okay. Then we have 2 times the power of 2 and 2. And then we have 2 times the power of 2 and 1. Then we have 2 times the power of 2 and 0. And at this point, we return 1. Returns 1. As power to 1 for previous recursion. Right? So it returns this one. We met our base case. Base case. Yeah, so that's the part, Anthony, that I have trouble on is I need to wrap my head around the fact that the function itself is waiting for a return value. We are returning a value and calling the function in a return, right? So the previous iteration, the previous recursion is waiting for the return from the next step. So that's what I need to wrap my head around over these next few days, is just constantly thinking that for these recursions, for this example, for where I'm returning the actual recursion itself, I'm waiting for that number to come back in my next depth, right? We'll do the debugger here after I write this out. So the base case is met, returns 1 as the power for previous recursion in place of power 2 1 for previous recursion. Recursions return value. Oh, hold on though. So, real quick question, you guys. We have Anthony. That when we met our base case down here and we return 1 when n equals 0, we're returning 1, but are we multiplying 1 by x still? So n equals 0 in this case, and 1 is being returned via this statement here. Are we still multiplying our 1 value by this 2 in our return statement? Or do we not even get there because this if statement is met and 1 is returned, not this statement here? I think that's the latter, right? Because we are stopped at line 4 or at line 3, and we have to return 1 here rather than returning this. Got you. Exactly. Yeah, not at all. We're returning 1 because we're stopped at this point. We don't actually ever reach this else statement. Two times power gets called, it still returns 1 because we are met with this condition. We never actually get into this else statement because our n is satisfied here. Okay, so this returns 1 in place of the power to 1 for the previous recursion's return value. So then this becomes 2 times 1, which equals to 2. Returns 2 in place of power to 2 for prev recursion return value, right? Then here we do 2 times that 2 that was returned, which gives us 4, which says returns 4 in place of power 2 3 for previous recursion's return value, right? And then in this case, Anthony says the function below it, 2 times the power of 2 and 0 returns 2, not 1. Yeah, exactly, right? But we never get into this else statement because we're satisfied by this if statement initially. Our n is 0, so we will return 1. We actually never get into this performing of taking our 1 and multiplying it by our x value, or 2 in this case, because we were satisfied at line 3, right? So this return 2 times 4 equals 8. Returns 8 in place of power 2, 4. For the previous recursions, yeah, power 2, 1 equals 2 times power 2, 0. You're missing one trace. I'm missing a trace. No, but you guys, this is our base case, right? Power 2, 0 returns 1. Yeah, so power 2 1 is returned 1 right here. But we have to multiply it by 2, which we do right here. Right? Because we have 5 levels. 1, 2, 3, 4, and 5. Two times power of 2, 1 equals 2 times. There are 6 levels, not 5. So, yeah, 6. I have 6 here. 1, 2, 3, 4, 5, 6. The 6th level is just 1. Exactly, right? These are my levels. So when we reach our base case, we return a value of 1. We're not returning on our base case 2 times 1 because we're stopped at this 3 line. Because n equals 0 here. N is 0. So we are stopped at 3. We do not perform this next recursion down to, this would be n minus 1. No, this does not execute another trace in my opinion, because we're at n equals 0. We're at 2 times power of n equals 0. So this will return 1, but it still has to be multiplied by 2. So then this will become 2 times 1, 2 times 2, 2 times 4, 2 times 8, 2 times 16, 2 times 32. So then we have see, we should end up on not 64 though. 2 to the power of 5 is not 64. See, this is wrong. $32. We were right before. Oh no, 32 gets returned to this value. That's why. There's no recursion happening at that point. So 32 gets returned as this value, and we're not multiplying 2 times p here. So 32 it gets as our value is 32. Because there's no 2 preceding this initial run here. All right. Forgot how to do this. Why is it to that? This glitch. Why is my thing so small? Come on. What are you doing over there? What's going on? Get out of here. Come on. Why is it doing this? Here we go. Okay, we set a breakpoint on the return, and we run the debugger here. Debug. Oh, it does. We have to actually call the function. Print 2 and 5. Okay. So then how do we move forward in the debugger? Don't print. Okay. Okay, here we go. Next. So this is our call stack here. Step over, continue, restart. Okay, we're restarting here. Use the buttons up top to move. Okay, yeah. So then we'll say n equals 3, n equals 2, n equals 1. Okay, so the power of 5, 2 stays on the bottom. Next. Power of 3, of 2 to the 3 goes next. Power of 2, 2 goes next. Power of 2, 1 goes next. What happens if you press step over? Just the next step. All right. Okay, at this point we've loaded not our entire stack. Oh. Yeah, the power is being populated each time. And our points. Interesting. So the 8 gets returned. Base case met returns. So this return, base case met returns 1. Replace a power to 0. So then 2 times 1 is equal to 4, or sorry, 2. And then this becomes 2 is loaded into here. Like so. So the base case is met when we reach here. For power, base case is met, n equals 0. Returns 1 in place for power 2, 0. 2 times 1 equals 2. 2 is returned to the previous recursion's return value. As here, 2 times 2 equals 4. 4 is returned to the in the place of the power previous recursion true value. 2 times 4 equals 8. Returns 8 in place of the previous recursion value. And then 8 here gives us 16. Returns 8 in place, and so then here 2 times 16 equals to 32. Returns 32 in place of the power 2, 5 for previous recursion return value, right? And so no additional math needed on original function call is returned to it 2 to the power of 5 is equal to 32. Cool. Awesome. That's the recursion trace for this function. Ugh, that was a doozy. I'm not gonna lie, guys. Thank you so much for bearing with me here and sticking along. This has been pretty difficult so far today, and pretty challenging for me to wrap my mind around a lot of these this terminology. Cool. So each of our stacks here, and if we go one more forward, returns power 4, return power 8, return power equals 16, return power equals 32, and the function's done. Ah, cool. Interesting. Okay, let's go back here. Okay. All right, anything else that we should add to this one? Anyone have any, you know, suggestions or information that we should add to this recursion tree? So, right, we start out with the power of 2 and 5. We start with the power an x value of 2 and an n value of 5. We know that if n ever equals 0, we return a value of 1, else we do this function here. So we know that we are breaking our n down by 1 each time, so our next recursion becomes x times this recursion call. So in this case, it's 2 is given as our x value, so it becomes 2 times the power of 2 of n minus 1, so 5 minus 1, or 4 in this case. The next one becomes 2 times the power of 2 and 3, 2 times the power of 2 and 2, 2 times the power of 2 and 1, and 2 times the power of 2 and 0. Oh, and our base case is met right here, so we return 1 in place of this power 2, 0, but we still have to multiply it by 2. So base case is met, n equals 0, returns 1 in place of power 2, 0. Returns 1 for power 2, 0. 2 times the 1 is equal to 2. 2 is returned to the previous recursion's return value as the previous recursion's return value. As right. So we return that 2. So we return in place of this, which becomes 2 times 2 equals 4. The 4 gets returned in place of the previous power iteration or recursion. The 2 times 4 equals 8. 8 gets returned as the previous power call. 2 times 8 equals 16. 16 gets returned as the previous power call. 2 times 16 equals 32. 32 gets returned as the previous power call. Oh, no other operations are here because we were on our starting case. And so we return 32, and that is reported, which is equal to 2 to the power of 5. So this one is done. We got this one. Cool. These ones are hard, guys. I'm not going to lie. We've been streaming for 3 hours and have gotten 2 problems done. Oh my gosh. That feels like such a fail, honestly, but like it's not because we're learning stuff. But in terms of check marking things off, it's been a rough one here. That's okay. Okay, nice. Draw the recursion trace for the computation of power using the repeated squaring algorithm used. Okay, I'm not going to do that one yet. We'll save that one for another time. Oh boy. All right, let's quickly give a check here. Okay. All right, you guys, let's go ahead and shift our focus here to the small business manager. I know a lot of you guys have been waiting for that one. So git add. We're gonna add continued chapter 4 reinforcement problems. We'll push this. Cool. All right. Let's open a small business manager. Okay, so last night, you guys, we decided that we needed to edit this. We needed to do some stuff to it. Um, so let's think here. So we need to refactor the item class to encompass all attributes associated with the item chain lifecycle. We need to remove the child class instances, creating new instance variables under the item class to flag these shifts in status from item to for sale to sold item. So let's go ahead, and here we're going to add in a couple of parameters. So we're going to add in a date listed is equal to a stir, which is going to be none. We have a date sold. Here's to a stir. Oh, sorry, oops. Put the none. And then for these optional parameters, we need to add in listing price equal to int. And then we have which is going to be a default of none as well. So then and then here we'll have item, or not listing price, sorry, item sold price is an integer, and we're going to equal none for right now. Okay. So I'll take this guy, copy it. Date listed is right before date sold, so we'll put it at the bottom here. If date listed, boom. That takes care of the for sale item class. And then sold item class, we need to take self dot listing price is equal to listing price, right? And then self dot sold price is equal to sold price. Okay. And then if date sold, we'll take this. Like that. Okay. And then we can remove the sold item class. Okay, so we now have a singular item class which will take in the instance itself. We'll give it a name, you give it a cost of good, you give it an item size, a number, you give it a listing price, a number, these are required, and then you can give it a listing price for if it becomes listed. Let's see here. Do I use black? I think I do. Yeah, I do use black. Okay, so we have listing price is none. We need a We can give them we need to have it like, is it sold? Yes. Date sold. Should we add in, do you think it'd be useful to add in a flag for is it listed or is it sold? Or do you think having the date listed and date sold is enough? Meaning that if we have values for date sold or date listed, that means that that instance is true. Or should we just directly input a flag that will detect, is it sold? Yes. Is it not? No. True or false? What do you think? Um. Okay. So name gets saved to name. Cost of good gets saved to cost of good. Size gets saved to size. Number gets saved to number. Listing price gets saved to listing price if provided. Sold price gets saved if provided. If they provide a date created, we will give it, else we'll override it to today. If they provide a date listed, we'll use it, else we'll use the date today. And if they provide a date sold, we'll give it, we'll use the date today. Okay. So this looks fine to me. So then what we need to do is in our function here, we need to now update the load and save file functions to not allow for these flags. So then this will get removed. But we need to put in the attributes that is required though. So let's take out these. Boom. That gets removed. And we'll say date created. What's the next attribute after date created? Or so we have item name, cost, size. Item name. Okay, so looks like I do number first in here. So what I'll do is item number up there, just to keep things organized. Item number, name, cost, size. Item number, name, size, cost. Okay, so we'll do size before the cost. That's like a descriptor. Okay. Date created is the next one. So date created is the next guy up. And then we'll have date listed, listing price, date sold, sold price. Okay, like that. So then what we'll do is we'll come over to our function here. And we'll say, right here. So so item number is 0, item name is 1, index 1, item size is 2, cost is 3, and we integer that. We int the number. Date created is 4. Date listed is equal to row 5. Date listing price listing price is equal to row, I'm yawning like crazy over here, guys. Date sold is going to be equal to row 7. And then sold price is equal to row 8. Okay? So we added in 4 more attributes here. Date listed, listing price, date sold, sold price. Okay, so then we need to actually assign these from when we're creating them. So date listed is equal to date listed. Listing price is equal to the listing price. Date sold is equal to date sold. And then date, the sold date, sold price is equal to sold price. Like that. Okay? So now that will generate items containing all of these attributes. And then we need to remove these. Boom. Remove this. Yes. Remove this. Yes. Okay. And then for our headers, we'll do, for our headers is going to be, after date created, it's going to be date listed. It's going to be listing price. It's going to be date sold. And it's going to be sold price. Right? Cool. So that takes care of that. Oh boy, pardon me, guys. Yawning like crazy over here. I might need to take a break for some dinner here in the next half hour or so, and then maybe come back for another late night stream tonight. Not late night, but just an evening stream. So we'll see if I need to take a break for some dinner here in a second. Okay. So now we will successfully read the items provided. We will append each of those items to a list and return loaded items, the loaded items list. Now that will return a list object. We don't want to do that. So what we want to do is we don't want to append each item to the list. We want to say if we want to assign it to the all items dictionary, I'm going to go like here, I'm going to go I want to return a dictionary. Loaded items is going to be a dictionary, right? Return a blank dictionary. So we need to return a dictionary, and we need to set the so we have the item created, so now we need to actually add the item to the dictionary and set the key to the item number. So we'll say loaded items, which is a dictionary. Key is going to be item number. Value is going to equal item, right? So we are going to index or like access the loaded items dictionary, we are then going to assign the key value to this item number, and we're going to save as the value in that key as the item itself. And then we're going to return all of the loaded items that we found within these pre-existing data point datas, right? So return loaded files, so loaded items. So loaded items will be returned right here on the, we have the save happening here. Where's the load? The load's happening in the main. So we will load file type items, and we'll save this as all items as a copy. Right? So this will return a dictionary that then gets saved as all items dictionary, right? All right. So now, then if we save, we need to adjust the saving that's going on, right? So we updated the load file. So then when we save, we have a run add items, so we'll take that out. So load does its job. Now a save is going to be if not type is this. We'll just leave that with open. We do item date created. Header is date listed. We have quote listing price. We have quote date sold. And we have quote sold price as our headers for writing. And then we'll write item dot date listed. We'll write item dot date or listing price. We'll do item dot date sold and item dot sold price. Cool. So then I'll just copy these little notes over for my personal use. Index 5, index 6, index 7, index 8. Cool. We only have 7 here. So number, name, size, cost, date created, date listed. We need here quote date. We have a date list already. We have listing price. So we need to take this date created, date listed, listing price, quote date sold, quote sold price. Hold on one sec. Missed it. Oops. Okay. So number, name, size, cost, date listed, listing price, date sold, and sold price. Okay, all those are good. So then we're going to write. Oh, hold up. I goofed up. So we don't need to. This is for the for sale items. Whoops. That gets deleted. So now we have item number, name, size, cost, date created, date listed, listing price, date sold, sold price. Cool. So that takes care of the write. So then when we read we're doing a load file on items. We're saving that as the all items because this will return a dictionary as loaded items, and we'll save that as the all items. If user input is equal to, we run exit. Okay, so I think we're good to maybe go ahead and test this. Okay, let's try it out. So main.py run. Okay, yes. Inventory. Find, edit. Let's add an item first. Or let me go to my items here. Going to delete these. Delete, delete. Okay, I'm going to delete the files themselves so we can have those new headers being generated. We run one. Inventory, add item. Okay, so our item CSV was made. It has all 8. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 9 parameters. I thought there was 8. 1, 2, 3, 4, 5, 6, 7, 8, 9 parameters. Oh, okay. Am I missing one somewhere then? I thought I only had 8. 1, oh, 0 to 8 indexing. So 9 there. 2, 3, 4, 5, 6, 7, 8, 9 there. Then how about in the load file? We have 0 to 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, cool. We're good. So then if we go, item name is test, cost is 10, size is medium, use today's date, quantity would be, let's just say 1. Okay, so now we get an error here. This is for the generate item number. Okay. We need to edit. We're taking in the lengths of these lists that don't exist anymore, so we'll get rid of those. Let's try this again. Yes. Inventory, add item, test. Cost is 10. Item size is medium. Use today's date. Quantity 1. Okay. Keyword items. Okay, so we need to revise this. So in our generate item number, it's the length of the all items keys. Right? If we do the length of the all item dot keys, we can determine the length of all of them, and that would give me the total, the next item number, right? So let's try that now. 1, inventory, add item, test, 10, medium, yes, 1. Object has built-in function or method has no length. So if I do dict.keys, what does that return? In Python, dict.keys is a method that returns a viewable object of all of them. We can list the keys. Okay, so it gives us a dictionary object rather. So what happens? So this generates a, I list the keys, find item number 1. Oh, hold on. Whoops, wrong thing. Find inventory add item, test 10, medium, use today's date, quantity 1. It's not iterable. So would give me a list of all the keys. My dictionary equals this. My print keys prints this. You can convert it to a list. So then what happens if I just return in my run add item? If I print, this is trying to generate the item number. So what if I need to access the last entry of the dictionary. How should I do this, guys? So right now we are trying to our items are being loaded as a dictionary where their item numbers are becoming the keys, right? So we need to generate an item number using the keys. You call length on dict keys. When you call it length, it was rolled an error because dict, the keys method, is not an object you can directly measure length. Correct syntax is the length dict.keys, which returns a number of keys. Okay, key.keys plus 1. So if we run this, 1, inventory add item, test, 10, medium, yes, 1. Okay, so now we get this key error. All items, pen. Okay, we need to go back to the load function. Where's this at? Line 120? Here. So all items generate new item. So we're going to save this to all items. F string here. We'll put in the item number here and set this equal to the new item that we've added. Okay, there we go. Now let's try it. Oh, whoops. So 1, inventory add item, test, cost 10, size medium, use today's date, yes, quantity 1. Okay. Here we go, guys. Here we go. Moment of truth. If we save inside our items.csv, we should see that item populated with all of its data. So let's go main menu, exit, yes. Okay, so we have another error. Okay, we need to do that same fix to the save file. So line 276. We have in our save file, we have for item in all items, we want to right row. For key and value of all items unpacked, how can I unpack the all items dictionary? Unpacking is not allowed in this context. I have to say dot values, no, dot for key value in the all items dictionary dot items, right? We need to call we need to right row for the value. This is for item. This is item number. Okay. So now if we try this, one, inventory, add item, test, cost is 10, item size is medium, use today's date, yes, quantity, let's make 5 of them. Main menu, exit, yes. Save file type equals for sale on line 256. Save file type equals quote for sale item. Oh, hold on, I need to change this part here. On our save file, when we exit the program in our run system here, when we save, we want to save file for type quote items. Okay, like that. Now let's run here. Yes, inventory, add, test, cost is 10, medium, yes, quantity 5, main menu, exit, yes. All right, moment of truth, you guys, moment of truth. Oh! Wait. Okay, so we have something going on here where, right, because we have none being filled in for here for date listed, date sold, and sold price. So should I instead inside of my items class make the date created instead of being none is false? Date listed. If there's no date listed, this is also false. If there's no listing price, this is false. If there's no date sold, this is false. And then if there's no sold price, this is false by default. So sold, this has to be an integer though, so this would be 0 rather for sold price if there's none. Listing price would be 0. Date created, date listed is false, date sold is false. Sold price is 0, listing price is 0, cost is whatever they put in. Okay. So now if I get rid of this guy, run the program, yes, inventory, add, test, 10, item size is medium, use today's date, quantity is 5, main menu, exit yes, items, we have a gray one, a blue one, a tan one, a green one, a brown one, a light blue, a light green, and a blue. Okay, so we have all 9 things are being met now. So, oh, but because we're providing false within our definitions here, so if date created, provided, you give one. So maybe we should actually keep these as none. We need to keep these as none. And then we'll keep this one as none as well. And listing price will be 0. Sold price will be 0. So then let's take these out. Let's try that one more time. Yes. Inventory add, test, 10, medium, yes, quantity 5, main menu, exit, yes, items class, we have a blue that's associated, one, two, three, four, five, six, 7, 8, 9. So by default now though, if we're not providing one, we're automatically assigning it to today. So we shouldn't be doing that. We don't want to assign it to today. We want to keep it as none. If not date created, then we'll go ahead and assign the none value to it itself. So if not date, and then if we do override it, then we'll set the current date. So if not date listed, we'll assign it. Else there is a date listed, we assign it to today. No, we don't want to do that either, actually. So if the user provides a date created, we set that to the date created. Elif, so when you say elif so should I say none here or should I say false? Because right now I'm being assigned the current date for the none value, right? So if the user provides a date created, then we use that date created that they provided. Elif else use the current day. So we need to say then, like, if the state created is if the status of the item, we need to have another parameter saying if for sale becomes true, set for sale price to so if the user provides a date created, we set the date created. Else we use today. But if we use today with the default value of none, how should I do this? What do you guys think? How should we go about doing this? Should we add more attributes or parameters to our attributes to our item and say like a flag, a true and false flag for sale and sold? And then say if that flag is sold, then if that flag is true, then we will go ahead and assign a date created. If so, we have to say like if the flag, right, is equal to true. No, so not for date created. If the date listed, if the flag for date listed, so if flag is equal to true, meaning that we have listed this item, we set the listing price to whatever they provide. Date listed. Stir. Listing price. Date sold. Stir. So what if I don't have any optional parameters? Would I make them all required? And then say that if the user provides a date I don't know, guys. So if there is a date listed by the user, we're going to assign that to the date listed. Else if flag is equal to true, I don't know what to do here. So item number is integer, item name is string. So we need to handle these optional cases where the date created, the date listed, the listing price, the date sold, and the sold price. Because right now they're automatically being assigned to today's current date for the listing date listed and the listing price date sold. So if the user provides a date listed, use it. No, we would want to access this item. We would never be creating the item and having it then be sold. We'd have to create it as an item and then transition it and transact it to be sold. So what we should do is the date created will be today. The date listed, will, if provided, will be given. We don't want to use the current day if it's listed. If date sold, use that date sold. Else use the none. So now if we go delete this and run our program, yes, inventory add item test, 10 medium, use today's date, yes, quantity 5, main menu, exit, yes. Did you mean date created? Uh-oh. So in our function here we have save file on line 282, date listed at index 5 is having problems. Item has no attribute date listed. Okay, so look like this actually and say else is equal to none. So none. Is equal to none. Okay, so now what happens if I do this? Yes, inventory add test 10 medium, yes, 5 main menu exit, yes, items, boom. Okay, so now we have that none value that's being saved for the date listed, and then we have a none value being saved for date sold, and the listing price is 0. Date sold is 0. So I kind of want to make these, rather than being zeros, I want to make them nones, because I don't want to have zeros in there. Like technically a 0 would mean the item was given away for free. So we want to then say in our items class that can int instance variables have default values of none. Yes, instance variables in Python can have default values of none, including integer type instance variables. Okay, so we'll make these none as well, rather than 0, and we'll say right, we need to say these same things. So I'm going to copy this guy, or we'll say down here, if date, if listing price, right, set self dot listing price to equal listing price, else self dot listing price is equal to none, right? And then if So listing price, this one would go in between the date sold here, and then this one would go at the end. So if sold price self dot sold price is equal to sold price, else self dot sold price is equal to none. Okay, so now that does the same things as the other one. If I delete this, rather than zeros, we should have nones in there. So 1, inventory add test 10, medium, use today's date, quantity 5, main menu, exit, yes. Boom, items. Okay, now we have blanks for the date listed, listing price, date sold, and sold price. Cool. 1, 2, 3, 4. But actually sold price is not anywhere to be found here. So we need sold price. Class sold price, if sold price, set it. So we don't want to do these. So we have an item name. I'm going to move this just so I can have everything in the same plane as it is when it's called. So we have an item number, a name, the size comes next. Right? So we have the number, the name, the size, the cost. You have date created if given. You assign it, else use the current day. You have date listed if given, use it, else use none. You have if listing price, use it, else use none. And you have if date sold, use it, else use none. Sold price, use it, else use none. So now I'll delete this. Yes, inventory add, test, 10, medium, yes, 5, main menu, yes, yes. And then items. So we have 1, 2, 3 spots, but sold price is not being. Oh yeah, it is separating because we have a comma. You don't have a trailing comma if you don't have anything. So for just to test it, actually, I'm going to set, just to see what it would look like, instead of if sold price, I'm going to set it equal to 1 and see what that looks like. So let's try that. We go, oh. Now let me also see if we get the override to item number 6. 1, inventory add item, test 2, cost 10, medium, today's date 5, main menu 3, yes. Okay, that overrode those files. So if I run this program again, main.py, go yes, inventory, add item, test 3, cost 10, medium, yes, 5, in menu, exit, yes. Okay, so it's overwriting and not adding into the next available spots. So what's happening there? We run our add, we generate the new items, and we set them equal to the all items list. So we don't want to set them equal to the next to all items. We need to set new item. We need to add it to the list, or add it to the dictionary. So adding objects to a dict. So let's say like we need to say an item to the next spot. How can I append, right? You can append to a dictionary in Python. You're typically adding a new key value pair or updating existing dictionaries in Python don't have an append method since it's a method associated with lists, but you can add or update entries using assignments or specific dictionary methods. Adding or updating a key value pair that updates it. Update. So B will append to that list. So we need to update the dictionary with the new numbers. MyDict update. And then inside the update here, we're going to include quote f string item number, and then we're going to assign new item here like that, like so. So now if we run this program, inventory add item, we should be getting the next item number, right? So item name, test 4, cost is 10, medium, yes, 5, main menu, 3, yes. No, that's still overrode on the save. So then what's going on here? So we have items is returning a dictionary, returning loaded items. We create a dictionary. So we have this loaded items going into our we're taking the item number, setting it equal to item. So what if we say loaded items? In our main function here, we load the items here and save it as all items. But that's not, it's happening on the creation. So when we create, we do a dot update. When we save, we're saving I'm not really sure what's going on with what kind of bug we're facing here, guys. So we know that we have our main function which loads the file by type items. It loads in all the pre-existing items into the list, into the program. So that would load all of these pre-existing items. Okay, we run our program, we add items. When we add an item, we get down to here and we say, we generate a new item number. I want to print item number here. See what happens. So we are updating our all items dictionary for this item number and this item itself. So the update method allows you to add multiple key value pairs at once or update existing keys. So override. No, so we wouldn't even need to update here, I don't think, actually, right? Because we can just say my dict with the item number new item, right? So that will place the item number as the key and place the new item as the items in our all items list. So we have an all items dictionary. We access inside of it. We paste the item number as the key, and we paste the new item as the value. So if I run this, go 1, inventory, add, test, 1, medium, yes, 1, 4, and I see this, 3, yes, it overrides. Why is it overriding where in our function is it overriding all items? So let's search for all items and see where we're touching it. Okay, we load the file. Okay. We take all items. So right, it would be on the right, on the saving. For item number, an item in all items. Items, we write the row. Any ideas, you guys, as to why we aren't getting, why we're overwriting our file? Find by item. So we're not using that yet. So all items is there. We load the file using the items. So then on our run add item, I'm going to add in a print statement here for print no, not there, we need to add it. Oh yeah, so right here on that run add item, we're going to print all items. So I want to see if it's overrode at this point. So we should see this in there, and we should see other ones if we make some more. So here we go, let's try it. Yes, inventory, add item, tester, 10, medium, yes, quantity, 5. I'm going to delete this. Actually, I need to put it here. I'll put it here. So now let's try it. Yes, inventory. So we have nothing in inventory right now. So we should have an item in there. So it's not reading my items appropriately. We should have an item in there. Okay, so we're actually not getting an item in there at all at this point. If I run, yes, inventory, we have the empty all items dictionary here. We should have an item in there. So I'm running load file for items. Load file is returning a dictionary. Item number, name, size, cost, created, listed, listing price, date sold, sold price, date sold, date listed, listing price, cost, date created, cost, date created. So the order is fine. So we're loading the item and we're returning loaded items here. So what happens if I print I'm going to comment out this for now. I'm going to say, what happens if I print at this point all items? Okay, so it's detected right there. So the file, the load is getting it. It's getting it correctly. And it's putting it in all items correctly now. Okay, so that's fine. So now when we run the system, so all items now has all the loaded files, loaded items. When we run system, yes, yes, it becomes empty. Why does it become empty when we get into the system? So run system, if we press inventory, why do we lose the all items? all items. So if I print all items at this point and don't run, we get the item that's in there. Okay. So then why, when I run, when I actually run the system function, do I lose all those items? So if I press 1, so if we press 1, we run inventory, we create a menu, we run add item, run add item, so I don't get though, why am I losing my dictionary? Yeah, it just overrides. So I'm not running the debugger because I don't have a bug necessarily, like an error. I have a right now somewhere in my program my files are being overrode, like my previous existing ones. They're being loaded in and they're not being maintained. So when I do the run here and I print all items here, right? If I do this, I go yes, we get the system. So let me take this actually, print, go here. Print all items there. Boom. We'll run here. Inventory. No, main menu. If I press. So it should have printed right here. Why did it not print? Why is this not printing all items right here? But we have to get user input first. So then print all items here, and then let's not go into inventory. Empty. So why does my all items dictionary so does this, oh, let me go here. Okay. Now how about that? Ah, okay, so it was not accessing the global variable of all items. So we global all items here. We added in. Now that will do that. So then we need to run the inventory function, which will do this. Run add item. Add item will so then if I go in inventory, add item, I have an item already in here as 1 and test, so we'll make this new item. 10. Item size is medium. Use today's date, yes. Quantity 5. Main menu, exit, yes. So this should not override. Boom! Woo! We did it, guys. Oh my gosh, like an hour of debugging later. Jeez Louise. Oh, this is so brutal. Today has been just I thought it was going to be a lot more smooth sailing, but we've been really, really grinding today. Ugh. Thank you guys so much for sticking with me here. Okay, so we were successful now in... Okay, cool. So what we were doing before, I'm not sure why we didn't have to call global before when we actually loaded these files. We didn't have to call global on the empty dictionary before when we actually returned these values to it. So, oh, because we assigned these to a key. And you can assign them to a key, but to actually access and override the entire variable, I think we had to global it, right? Because before we were doing, we were assigning the list that was returned with all the items in it to the key value of all items. So that's why it wasn't working. So we had to global it here to access the global variable of all items, so that we can override the blank dict with the current files that are the items that are in the current file, and then so we can remove this here, and then when we run the inventory, when we add an item, we generate that item and use the all items list. And for generate item number, what we do is to generate the item number, we return the length of all of the keys. So the keys are going to be just all the individual item numbers starting from 1. So if we know that we have 5 items in the list, well, we have 5 keys. So we just return the length of the keys and go up 1 to find the new item number. So, and that's what it did here, is we had 1 in there. So now if I go ahead and run the program one more time here, you guys, and I'll keep open my file here. So right, we ended on item number 6 on this new item. So I will go ahead and say yes. Sold price is 1. Oh, because I overwrote it. Yeah, so we're also seeing that the sold price, so you don't get a trailing comma in a CSV file if you don't have another value next. There's no trailing comma for the last value. Okay, that's good to know. So if we go inventory, add item, let's just make this completely random, like this. Cost would be 10. Item size is large. Today's date, we'll say yes. Quantity, let's say we have 20 of these. So we should see item number 7 through 27 be populated here when we exit out of the program. Or 7 through 26, sorry, because it's awesome. So we have 7 through 27. Yeah, line item 7 through 27. Cool. For 20 total items. Oh, nice. Okay, so then we need to go back to our item class and set this back to none rather than 1. So now if we remove all of these items, we run the program, go yes, inventory, add item. We'll say this is a dress. Cost us $10. It's a medium. We're going to use, we acquired it today. And we'll say we found 1 of them. Okay, we're going to go, let's add another item just on top of that. We'll make this shirt. Cost will be 20. Item size, let's say this is a small, yes, and one of them. Let's exit out of the program. Right, you should see those populate right here. Boom, those are populated. Dress, shirt with the appropriate things, and we have the appropriate blanks for the additional parameters we need to override when the item actually gets transitioned into for sale or sold. And then if we go ahead and run the program one more time and add items on top of those, let's say test item 2, or test item, let's say this is going to be item 3, right? Item, or tester, let's just say tester. Cost would be 10. Size will be extra small, for a better example. Yes, today's date, and let's say we have 5 of these, right? We should see these appropriately go to the next item numbers and populate into our list here. So main menu, exit, yes. 1, 2, 3, 4, 5. Boom. Woo! Yeah, we're doing it, guys. We're doing it. Sorry about your ears if that was a little loud. Okay, so we have successfully converted our program over into a single class object that handles all of the attributes for this transition. Now, we now need to holy cow, that looks complicated. Why? That's why doing pseudocode helps. Yeah, definitely. Congrats. Thank you so much. That looks like setting instructions to make some peanut butter sandwich. You earned some water. Yeah, for sure. Definitely. All right. So now what we also can think about doing though is we are dealing with the quantities outside of the function, right? Our quantities are a tertiary integer value that just multiplies the item number by the quantity, right? And so, and that way each additional quantity gets generated with a unique item number. See, if I have the quantity within the class itself, the item numbers for each quantity would not be the same, or would be the same, right? And so they would not have unique item numbers. So I'd have to add an additional parameter, such as like a lot number, to differentiate those same item numbers, right? So I'm not sure how I want to go about that. I kind of want to ask Anthony, or not Anthony, yeah, Anthony, what his opinions were, because he had some thoughts about it yesterday. Um, because, right, if we have a quantity attribute that's associated at the class level, then let's say that, right, we have that means we'll have 5 of the same item number, right? Item number becomes, if item number is 1 and we have 5 of these items, well, in this, how it's set up currently is we'll have 5 um, item 5 items with the same number. And so, but each item needs a unique number. That Toxic Gamer says, "Oh wow, I'm new to this coding thing. Just started CS50X from Harvard University. I did not know Python used the same coding as C." I think a lot of them use a lot of similar syntax with just some different overall, you know, a lot of them use like the similar kind of flow and stuff like that, but there's the syntax is a little different. But yeah, I started with Harvard CS50P, so that's really awesome that you're doing CS50X. I was actually thinking about maybe doing that course at the new year when they release the new curriculum for the CS50X, and then also streaming it to the channel. So yeah, we'll definitely maybe be taking a peek at CS50X come the new year at the end of December this year. I've been waiting just for that new curriculum to come out in 2025. So, but yeah, that's really awesome. Thanks so much for joining. I appreciate you. Shadows, thanks so much for coming in. That's nice. There's a lots of people into programming, just a job market that sucks right now. Yeah, no, definitely. I have a bachelor's of science in human biology and a minor in chemistry. I work as a formulation chemist, so I'm doing this completely out of just independent drive and willpower of wanting to learn and wanting to take on new hobbies and skills. So I don't have any pressure to like find work. So that way I've removed all the pressures. It's just completely about the enjoyment of the programming, and there's no more like a I need to get work or learn this because I need to pay bills. No, no, no. It's not like that. So which makes it a lot more enjoyable. Do it is really good. I've been on it for 2.5 weeks and it's good. Awesome. Yeah, I should definitely take a stab at that, and I could provide it as another resource into the Discord. The Discord below is just a compilation of all my study resources, from PDFs of the books I'm reading to practice problems I've done to project showcases to everything. So if you want access to all my independent study resources, I just have created a Discord to compile all of them into one location. It's completely free. Thank you so much, Shadow. That's such a nice comment. You're so kind. Thank you. Okay, I'm gonna take a little break right now, guys. I'm gonna grab some dinner, take my dog outside. I'm gonna probably come back on stream in about maybe 2 to 2.5 hours. So if you're interested in seeing me work more on this independent small business manager project we're working on, where we're taking in items, converting them into sales, tracking the sales, developing income statements, cost of good reports, expense tracking. It's a one-stop shop for a small business owner to be able to manage items and generate reports and expenses and stuff. So this is our personal passion project we're working on right now. And then at the beginning of our streams, we read, textbooks and do learning so we can actually implement stuff. And what's really cool is in my function here, in my program, we have a find item by function, and I actually wrote this yesterday, and it's a binary search algorithm. And we learned about binary search algorithms in chapter 3 of this book. So we took what we learned, or I'm sorry, we learned about binary search algorithms in chapter 4 of this book. And so we took what we learned and we directly applied it into our program here. So we're not just, learning things for the sake of it. We are actually trying our best to apply them into real world scenarios. So which is really awesome. So I don't. Again, we need to do some little bug fixing on this function, because we did adjust our class to be just a single one today. We refactored heavily on our program today to set us up for success in the future. But I will see you guys in about 2 hours. Thanks so much for joining so far. We streamed for about 4.5 hours today, so far. But I'll do another about maybe 2.5 or 3 hours this evening at around 8:30. And so I'm just gonna grab some dinner, take a little break, go on a walk with my dog, and then I'll be back to keep learning and grinding away. And so thank you so much, you guys, for let's check on the old YouTube channel here. Uh, check here. 454. We passed 450 subs. Thank you so much, you guys. Woo! Whoa, what is up with that? I didn't know it did that. What was up with that? That was crazy. What was that? um, yeah, we passed 450 subs, so excited about that, and thank you so much for all the support in that. And if you're wanting to see, I have a task tracker project. I posted a demo video of it. We wrote this live on stream, just like I'm doing this current project. We're just leveling up one project after the other, adding on additional features with what we're learning. And then, yeah, so go ahead and check out that video. Join the Discord link below. I'll be back in about 2 hours to go over. 2 thumbs up should do that. Oh, that's so cool. Now when I get programs right, I can do that rather than just scream. All right, I'll see you guys in about 2 hours. Thanks so much for stopping in today. Bye, guys. See you in a second.